Imagine spending like hours writing hundreds of lines of really complex code.
Oh yeah, just grueling work.
Right, and you painstakingly build this mechanism to comb through a massive file, successfully extracting exactly the precise piece of data you need,
Uh-huh.
and then intentionally you just throw that result straight into the trash.
It sounds completely counterintuitive.
It really does.
Yeah.
But today, we're looking at a piece of software engineering where doing exactly that is, it's not a mistake or a waste of time at all. It is actually the mark of a master craftsman. So welcome to the deep dive.
Thanks. Yeah, we are dissecting a highly specific piece of writing published today, actually, March 20, 2026.
Fresh off the press.
Exactly. The source is a blog entry from qianmeng.org, and the title is Notes on Haskell Programming, Part 87, Reducing String Packing Clutter.
Part 87. That is a lot of notes.
It is. And our goal here isn't simply to, memorize a niche technical trick in the Haskell programming language.
Right, because we are treating this single, highly specific technical post almost like a microscope slide.
Oh, I like that analogy.
Yeah, like by zooming all the way in on how one developer handles this tiny piece of what he calls code clutter, we get to see the really intricate, often super messy reality of how massive software systems are built and, maintained and refined over time.
Yeah, and before looking at the code itself, we really need to understand the environment it was born in and the mind that wrote it.
For sure.
The author of this site, Qianmeng Eng, describes himself at the very top of his blog with this rather humble phrase. He calls himself an old software plumber who spends his nights tinkering with free, Libre, and open source software.
Which is, that title is a stark contrast to how the tech industry usually talks about itself.
Oh, absolutely.
We are so used to that whole Silicon Valley ethos of move fast and break things, right? Where programmers are treated like wizards inventing magical algorithms out of thin air. But plumber implies something entirely different. Why would someone writing high-level Haskell code refer to themselves as a plumber?
Well, it implies maintenance at the infrastructure level of open source. So the libraries and frameworks that form the invisible backbone of the internet, the job is rarely about inventing magic.
Right.
It's about routing information. It's ensuring that massive streams of data flow efficiently from one system to another without, leaking memory or crashing.
Like actual pipes.
Exactly like pipes. And most importantly, it involves unclogging absolute messes left behind by older, poorly designed systems.
And the sheer scale of his documentation really proves he has been maintaining those pipes for a very long time. He has been blogging consistently since July 2011.
That's incredible dedication.
It is. In the year 2024 alone, he published 732 posts.
Wow, 2 a day.
Yeah, and in 2025, another 730 posts.
Uh-huh.
And by today, March 20, 2026, he has already put out 60 posts this month.
That's just staggering. And the tags on his blog reveal this incredibly vast breadth of interest, too. You obviously have notes on Haskell programming, but right alongside it, you find notes on fish keeping, part 212.
Wait, fish keeping?
Yeah. It details the tracking of betta fish spawn logs and strategies for managing aggressive fish behavior.
That is amazing. And you scroll a little further and hit notes on gardening, part 841, discussing bougainvillea propagation and the common mustard plant.
Part 841, he just keeps going.
Right. There are extensive notes on AI, typesetting, home improvement, and dieting, specifically exploring whether eating fish is a better option.
I wonder if the betta fish influenced that.
Maybe. He also publicly lists his support for digital rights groups, like the Electronic Frontier Foundation, the Free Software Foundation, the Tor Project, and Wikipedia.
Right. So what we're looking at is the public record of a polymath.
Yeah, it's like a modern-day Renaissance cabinet of curiosities.
Yeah.
But instead of, taxidermy and old coins, it's filled with Erlang libraries and aggressive fish management logs.
That is exactly what it is. And what connects all these seemingly disparate topics is a mindset of extreme observational rigor. He applies the exact same patient, methodical approach to watching a mustard seed sprout, as he does, to tracking a memory leak in a complex software library.
Okay, so we have this deeply meticulous software plumber looking at his code and realizing he has a clog. Or, as he calls it in part 87, clutter.
Right. He states clearly that he wants to reduce the clutter of constant pack calls in his Haskell code.
And let's establish why text in Haskell requires packing in the first place for the listener. Because, most people who have dabbled in Python or JavaScript think of text as just text. A string is a string. Why is Haskell so obsessed with how text is handled?
Well, Haskell is notoriously strict about memory and performance. In older standard Haskell, a basic string is actually defined as a linked list of characters.
Okay.
Conceptually, that is very pure and mathematical, but from a performance standpoint, a linked list is terrible for memory overhead. Every single character requires its own tiny block of memory pointing to the very next character.
Oh, wow. So if you are parsing a massive file, those standard strings will just eat your system's memory alive.
Exactly. Which is why the Haskell community developed more efficient types, like text, which stores characters in contiguous memory, or byte string, which handles raw bytes.
Makes sense.
But because Haskell has a rigid type system, if a function expects the efficient text type, but you are holding a standard string, you cannot just hand it over. The compiler will literally stop you. You have to explicitly convert it by passing it through a function called pack.
Got it. So it acts like a toll booth? You have to explicitly pay the toll to convert your linked list into an optimized block of memory.
Yes, that's a great way to put it.
And if you are doing that constantly, your code becomes visually noisy. Like
Mhm.
every other line has a pack command cluttering up the logic.
It gets really messy.
But wait, I know Haskell has a built-in feature called overloaded strings, right? It's a language extension you can turn on that automatically handles those conversions behind the scenes.
It does, yeah.
The compiler just sees what type is needed and quietly does the packing for you. So why is his primary directive for this post to figure out a clean way to handle text without enabling that extension?
Well, because implicit magic in code comes with hidden costs. I mean, overloaded strings is incredibly convenient for a quick script. But for an infrastructure developer, if the compiler is secretly changing data types behind your back, you lose explicit control over your performance.
Oh, I see.
Yeah, you might accidentally introduce massive computational overhead without ever actually seeing it in the code. Purists often avoid overloaded strings because they want the code on the screen to reflect exactly what the machine is doing, nothing hidden.
Okay, that makes sense. But he also places another constraint on himself. He explicitly wants to avoid handling this text by using manual string concatenation like the operator.
Right.
And this is where I actually find myself pushing back a bit. If I have two strings of text and I need them combined into one, my immediate instinct as a novice is to just smash them together with that concatenation operator.
Sure, that's most people's instinct.
Returning to the plumbing analogy, if I have two pipes and I need a longer pipe, I am just going to grab some duct tape and tape them together. Why go out of the way to avoid such a basic operation?
Well, think about the reality of maintaining a house where the plumbing is literally held together by duct tape.
Okay, fair point.
I mean, it holds water today, but when someone else comes in 5 years later to fix a leak, they are faced with an absolute nightmare of overlapping tape. In a strict code base, manually taping strings together creates endless visual clutter. Every line has operators sticking out, breaking up the actual logic of the program.
So you end up micromanaging the data flow piece by piece instead of setting up a clean structural pipe.
Exactly. Furthermore, continuous concatenation is often really inefficient. If you keep appending small strings together one by one, the program often has to repeatedly allocate new memory, copy the old string, add the new piece, and then discard the old memory. It is computationally wasteful.
Got it.
So the author is seeking a precise, structural solution rather than relying on a quick, messy fix.
Right. If we refuse the duct tape of concatenation and we refuse the hidden magic wand of overloaded strings, we need a highly surgical tool to extract exactly the text we want from the data flow, cleanly and safely.
And he finds that tool in a specific parsing library called Megaparsec.
Okay, Megaparsec.
Yes, specifically he uses a function called text.megaparsec.match. A parser's job is to read through a stream of text and make sense of its grammatical structure, verifying that it follows a specific set of rules.
And when you use this match function, it hands you back a data structure called a tuple, right?
Yes.
Containing exactly two things. First, it gives you the exact slice of text that it successfully matched from the file. Second, it gives you the parser's own internal matching return value, essentially the state or result of the parsing action itself.
Precisely. But the author only wants the first part. He does not care about the parser's internal return value at this moment. He just needs that sweet, clean text to flow through his pipes.
What does he do?
To isolate it, he reaches for a standard Haskell function called prelude.fsd, which simply extracts the first element of any tuple. Has just answer first.
That sounds incredibly straightforward. Hand the tuple to the tefs function, it grabs the text, and the clog is cleared.
It would be, except for Haskell's strict safety guarantees. The match function does not give you a raw exposed tuple. It wraps that tuple inside a specific computational context, in this case, a parser context. So the resulting type is actually parser text.
Wait, why wrap it in a context at all? Why can't the system just hand over the data and be done with it?
Because parsing is inherently risky. What if the text the program is looking for simply isn't there? What if the file is totally corrupted?
Ah, right.
In languages like Java or C++, a failed parse might throw an exception, crashing the program if you forget to handle it. But Haskell handles failure differently. It encodes the possibility of failure directly into the type system.
Okay.
The parser context is essentially a mathematical wrapper that tells the program, hey, this data is the result of a parsing operation. It might succeed, it might fail, and you are mathematically forced to handle those possibilities.
Let me try to visualize this for the listener. The match function has just handed you a locked briefcase.
Oh, I like this.
That briefcase represents the parser context, enforcing all the safety rules. Inside the locked briefcase is the two-part folder we actually want, the tuple.
Right.
Now, we want to use the ls function to read the first part of that folder. But sourced is a very basic function. Its only job is to read open folders sitting on a desk. If you hand it a locked briefcase, it just stares at it and throws a type mismatch error. It literally does not know how to interact with the briefcase.
That is a brilliant analogy. The types do not align. You have a function expecting a plain tuple, AB, and you are giving it a complex context containing a tuple. The compiler immediately halts.
So the pipes are blocked again. We cannot use our simple extraction function because of this strict safety wrapper. How do we get the folder read without writing paragraphs of clunky boilerplate code to unlock the briefcase, check for errors, take the folder out, run the function, and put the result into a brand new briefcase?
Well, he introduces the hero of today's deep dive.
Sure.
It is an operator rooted in the concept of a functor, and visually it is written as an open angle bracket, a $sign, and a closed angle bracket.
Okay.
This is known as the lifting operator.
Well, a listing operator. So if Faust is the guy who only knows how to read open folders, does this lifting operator essentially give him a pair of X-ray gloves? Or like remote control robot arms?
Oh, yes.
Can you see in scientific labs, right? He can use the arms to reach directly into the locked briefcase, manipulate the folder inside, read the text he needs, and leave everything safely locked inside the briefcase the entire time.
The remote control arms analogy captures the mechanism perfectly. A lifting operator takes a standard everyday function like fest and lifts it into a higher level of reality. It allows the function to operate over the value inside the context without ever needing to dismantle the wrapper itself.
So by writing frist, the code cleanly reaches into the parser, applies the extraction, and the result is seamlessly updated to parser text.
Exactly.
No dismantling briefcases, no manual type conversions, no duct tape.
None at all. It resolves a complex structural mismatch instantly and elegantly. Instead of cluttering the code with manual unwrapping and rewrapping, he uses a single powerful mathematical operator to bridge the gap. The data flow remains completely intact, and the visual noise is entirely eliminated.
But he doesn't stop there.
No, he doesn't.
We're dealing with an old software plumber who wants the pipes to be immaculate. Towards the end of part 87, he details another small refinement regarding how he handles the structure of the text itself. He discusses using a function called Control.Monad.void in his parser rules.
Right. The concept of a monad is fundamental to Haskell. It's another type of computational context used to chain sequence operations together. The author notes that using void is an alternative, visually cleaner version of a process where you run a parser, do the work to read the file, and then deliberately discard the result.
And this goes back to my question at the very beginning of our deep dive. Why would you write code, expend computational energy to parse text, and then intentionally throw the result directly into the trash? Isn't that like meticulously cooking a meal and then scraping it directly into the garbage bin?
Well, consider the reality of a complex configuration file.
Yeah.
It is full of structural syntax that matters to the parser but does not matter to your final database.
Like what?
Blank spaces, commas between items in a list, brackets at the beginning and end of a paragraph. The parser must consume them. It has to read them to verify that the syntax is correct and to move its internal pointer forward to the very next piece of real data.
Ah, so you have to parse the empty space to prove it is mathematically sound empty space so you can safely move on.
Exactly. You are checking to make sure the syntax is valid. But once you have verified that a comma is in the correct place, you do not need to save that comma in memory. Keeping it would be a total waste of resources.
It is like running a diagnostic burst of clean water through a newly installed pipe. You do it just to prove there are no blockages or leaks inside, and then you let that diagnostic water go straight down the drain before you hook the pipe up to the actual drinking supply.
Yes. And using void is a perfectly elegant way to express that specific intention. Because, code is read by other humans far more often than it is written.
Right.
When another programmer looks at this system 5 years from now and sees void, they know instantly. He checked the syntax to ensure the structure was sound, and now he is discarding the wrapper. It is a philosophy of total cleanliness.
So let's pull back and look at the whole drop of water again.
Yeah.
Qianmeng Ang set out to avoid the visual noise of constantly packing strings. He rejected the hidden, unpredictable magic of the overloaded strings extension. He rejected the fragile, inefficient duct tape of the concatenation operator.
Yeah, he really stuck to his principles.
He navigated the strict safety wrappers of Haskell by using the remote control arms of the lifting operator, reaching into the parser context to extract exactly what he needed. And he swept up the remaining structural dust by cleanly discarding unnecessary syntax data with void.
It fundamentally reframes how we should view the act of programming. It is not a frantic sprint to ship a feature by any means necessary. It is a craft of refinement. It is about laying infrastructure that will remain legible, safe, and functional for decades.
And there's a profound takeaway here for you listening right now. Whether you are writing Haskell, managing a massive corporate codebase, running a logistics team, or just trying to manage your own digital files, there's immense value in pausing, in stopping the frantic duct taping for just a moment to ask, is there a cleaner, more elegant way to do this, instead of just brute forcing a solution?
Because brute forcing a quick fix inevitably creates a maintenance nightmare down the line. Seeking elegance, even in something as microscopically small as extracting a string of text, is how you build systems that are truly resilient.
And that brings me to a final thought. Based on the sheer, overwhelming volume of Qianmeng Ang's blog, look at what happens when one person patiently, meticulously tracks their learnings, day after day, year after year.
It's inspiring, honestly.
It really is. Documenting the mechanism of a lifting operator in Haskell, right alongside tracking the spawning habits of a betta fish in part 212 of his fish-keeping logs, all the way to part 841 of gardening notes and part 87 of Haskell by March of 2026. He has essentially created a massive, interconnected public brain.
Yeah, a real legacy.
So ask yourself, what tiny daily clutters or random curiosities in your own life could you start documenting today? It does not have to be advanced mathematics. It could be family recipes, or the recurring friction points in your workplace, or the behavior of the birds in your backyard. If you just kept noting it down, refining it, exploring the connections, what kind of unexpected profound expertise might you possess if you just kept at it for the next 15 years?